Welcome everyone. It is 2 o'clock and you are in the management options for corn earworm in sweet corn webinar. We appreciate you all coming today. So a few housekeeping things to get out of the way right at the beginning here. Just so you know that if you would like a live transcription, at the bottom of your screen, you should just click on the CC and it will show a live transcript. This webinar is being recorded, so you'll see the recording. And then we will be posting it on the project website, cornearwormipm.org or cewipm.org, and we will post the link to that in the chat. Also, we really appreciate questions and are hoping to have a nice question and answer section after we get through a few of our talks. So feel free to submit questions at any time. We want you to use the Q&A feature. So that's the one that has this question mark in the box for asking your questions. And then we're going to group them together and use that as a discussion at the end for the Q&A session. So hold your questions to the end. There will be some points in the polling and other situations where you might want to chat. That's a different feature. But for questions, please use the Q&A. So, introductions. I'm Dr. Kelly Hamby. I'm an associate professor and extension specialist in the Department of Entomology at the University of Maryland. I received my bachelor's in environmental toxicology and my master's and PhD in entomology at the University of California, Davis. And I'm the project director for the regional team that's working to improve corn earworm management. And so more information about the project and the rest of the team members can be found again at that website. Today we have two presenters, myself and Dr. Veronica Yurchak. She's an extension specialist for commercial vegetable production with the University of Maryland Extension. And her program focuses on integrated pest management and sustainable production practices in vegetable crops, including sweet corn. She received her bachelor's in ecology and evolution, her master's in entomology, and her PhD in entomology at the University of Maryland. And we'd like to get started today by learning a little bit more about who you are. So we're going to launch a poll asking some questions about who our audience members are and what your experiences are with managing corn earworm in sweet corn. Okay, it looks like we have a lot of University of Extension professionals in our audience today, as well as some farmers and crop consultants. In terms of products that people are using, it looks like Besiege is relatively popular. Corrigan also relatively popular. Some folks are using attribute 2 and plus hybrids quite a bit. The majority, about 44% of people, do not use or recommend BT hybrids. And people are mostly to moderately happy largely with their corn earworm management. So I'll leave that poll up for one more minute as Veronica gets started. If any of you still need a chance to answer the questions, we appreciate getting a sense of who our audience is. And Veronica, feel free to take it.
Oh, okay. I'll start before the poll is over. Okay. So thank you all for being here. As Kelly mentioned, I'm Veronica Yurchak. I'm with the University of Maryland Extension. And today I'm just going to talk quickly about the current efficacy of BT sweet corn hybrids, mainly for corn earworm management, but I will mention the other pests also that the different hybrids are effective for. Here we go. So just as a quick overview, as we all know, corn earworm is the major ear-invading pest of sweet corn. It migrates seasonally from southern regions, so it begins building up its populations in the south, and then it moves up north as we get later in the season, mostly on storm fronts. And in Maryland, it's primarily active from May through October. So adult moths are attracted to fresh silks for egg laying, and they'll preferentially lay their eggs in sweet corn over field corn and other crops. And because of that fact, or because of the fact that populations are migratory, infestations will vary throughout the season and then from year to year. And so, as we all know, managing corn earworm with insecticides is very challenging. Kelly's going to talk a lot more about that in the next presentation. But just some factors that contribute to this pest being very difficult to manage is the fact that the moths lay their eggs on the silks, and when those eggs hatch, they quickly move down that silk tube and into the ear where they're protected from any insecticide sprays. So there's a very short window of opportunity for that insecticide to effectively control that pest. Also, because silking occurs over several days, newly emerged silks after an insecticide spray are going to be unprotected. So that gives the insect the opportunity to tunnel down into that ear without being exposed to those insecticides. And then just issues with spray coverage, and then, of course, weather-related issues and rainfall reducing the efficacy of an insecticide application. And so kind of one way to get around some of these challenges is to grow a BT hybrid. So these are sweet corn hybrids that have been engineered to express certain proteins within their tissues that are toxic to the different corn pests. So these proteins are expressed throughout the different tissues of the sweet corn plant, and then when the caterpillar feeds on those tissues, it consumes those toxic proteins and it's controlled that way. So today I'm just going to talk about the different kind of hybrids or trait packages that are available. So this is just a screenshot of a table that's in our new version of the Mid-Atlantic recommendations guide, which we just it's kind of like a modified version of the Handy BT trait table for sweet corn. And it just shows you the different trait packages, the hybrids, and what insects it controls, and then the herbicide tolerance. So I'm going to talk about these hybrids in the order that they were commercially released, but that doesn't match the order of the table. So the first transgenic products that were registered by EPA were the attribute sweet corn hybrids from Syngenta. So these were first commercially introduced back in 1996, and they expressed a single cry protein, or they do express a single cry protein in all of their tissues, and they are tolerant to glufosinate herbicides, or Liberty Link. And so following initial release for about 9-ish years, or the first 9-ish years, these provided pretty good corn earworm control. So they never provided 100% control, but compared to a non-BT variety, you would see relatively clean ears. So this is a photo by Galen, and it just shows kind of a comparison of what those attribute varieties looked like in terms of earworm damage without any insecticide sprays compared to a non-BT variety. As the years went on and resistance began to build in corn earworms, from about 2004 to 2009, we started to see more tip damage from corn earworm compared to a non-BT variety. And then now by 2024, we really don't see much difference with these attribute varieties, so expressing that single cry protein between the BT hybrids and a non-BT variety. So just to summarize, over the years with the attribute sweet corn, started off, we'd see about an 80 or a little bit more percent reduction in corn earworm damage compared to a non-BT. And then you can see how that steadily declined up to 2004, which was the last year that we really tested and compared what that looked like. But at this point, attribute sweet corn does still provide 100% control of corn borer in most regions. So there is a little bit of resistance showing up in kind of the northeastern parts of Canada. But for the most part, the attribute works very well for corn borers. It does not work well for fall armyworm at the ear stage. It's a little bit better in the whorl stage sweet corn, but still not great. The attribute varieties have no effect on western bean cutworm. And now that resistance has built up, they give you very poor control of corn earworm. So you pretty much need a very similar spray schedule in attribute sweet corn as you would in a non-BT variety. So a couple years after the attribute was released, there were the performance series sweet corn varieties that were introduced commercially. So this was in 2010 now that these came out. These contain 2 cry proteins for caterpillars and then an additional protein that targets rootworms. And unlike the attribute, which has glufosinate herbicide tolerance, the performance series sweet corn is tolerant to glyphosate herbicides. So just some pictures to see, when this first was released back in 2010, and for the first couple years after its release, the performance series provided pretty clean ears, kind of similar to what the how the attribute worked when it first came out. But fast forward to kind of 2017 to 2024 when efficacy really started to decline. Um, Now we do see quite a bit of resistance for corn earworm to also these performance series hybrids. So just to show you kind of how that decline has happened over the years, initially very similar to the attribute, so about 80% reduction in damage compared to a non-BT variety, and then that dropped down pretty quickly to about 50%, and now we're down to 16% or less reduction in damage. Um, so when it comes to the other sweet corn pests, still 100% control of European corn borer, again in most regions. The performance series do offer better control of fall armyworm now at all growth stages or crop growth stages compared to the attribute, and it's slightly better control of western bean cutworm. But when it comes to corn earworm, the performance series really don't work very well anymore. So you are going to need a similar, again, spray schedule as with a non-BT. Looking at now the attribute 2 and the attribute plus. So I'm going to go through these two kind of trait stacks or these hybrids together for the most part because they do have the same insecticidal proteins in them. So when it comes to corn earworm control, they're identical. The differences really come into play with the herbicide tolerance, where the attribute 2 has glyphosate and glufosinate herbicide tolerance, whereas the attribute plus only has glufosinate tolerance. So these were introduced back in 2014, and they contain two insecticidal BT proteins. So the original Cry1 protein that was in the attribute 1 trait stack, and then now also a protein called the VIP protein or VIP3A. So this has no cross resistance with the Cry proteins. It's a very different kind of protein that attacks the insect differently, and it's very effective against a wide range of caterpillars. So again, the protein is expressed throughout the corn plant. And I just want to, because these are the only ones that do have efficacy against the corn earworm, I figured it made sense to go through these hybrids in a little bit more detail than the attribute 1 or the performance series. So with the attribute 2, there are several different options. There's super sweet and triple sweet hybrids or varieties with a range of different days to maturity. Most of them are bicolor sweet corn varieties. Patron there is a shipping variety. The other ones listed here are all designed for fresh market. And something I want to mention, so the remedy has been shown to not perform as well under stressful conditions, just in terms of crop growth. So it has been replaced by revision. So seed for remedy is still available through various suppliers for 2026, but it's not listed as an active variety with Syngenta anymore. And it's my understanding that a new batch of seed was not produced for 2026. So going forward, it's probably going to be very difficult to find seed of the remedy. And the replacement is this variety called Revision. And then just one more is Protector, which is another shipping variety, and it's the only not bicolor attribute 2 trait stack. The attribute plus, which I said the only difference really is in the herbicide tolerance. So these are glufosinate tolerant only. There are 4 different varieties available, super sweet or triple sweet varieties. All of these are fresh market, except for this BSS 0761, which is also advertised as a shipping variety. And this one gives you a little bit more options when it comes to the color. So there are 2 bicolor varieties, but also a yellow and a white, which can be an important factor depending on what your consumers like. So just when it comes to corn earworm, of the 106 trials that we've done kind of across a monitoring network, only 1% of almost 14,000 ears showed any damage. So the VIP protein from the start works a lot better for controlling corn earworm than any of the cry proteins did, even when they were first introduced. There are some early warning signs of resistance occurring in Texas, but this is not practical resistance that's evolved in the field. It's just some lab studies showing some genetic changes that might be indicating that resistance could potentially be happening in the future. Um, Again, different herbicide tolerances between the two hybrids. And when it comes to pest control, both provide 100% control of the European corn borer. So that's with the cry protein. And then that VIT protein provides excellent control of all the other caterpillar pests. So corn earworm, fall armyworm, western bean cutworm, and the other cutworms. Um, in general, you don't have to worry as much about applying additional insecticide sprays in the attribute 2 and attribute plus for corn earworm. So these won't have any efficacy against sap beetles or stink bugs or any other corn pests that you might have in your area. And in general, just a note that without ear damage, they're typically the risk of sap beetle injury is a lot lower. Um, but just some take-home points. So all the BT sweet corn types or trait stacks provide very good control of European corn borers. Corn earworm is resistant to the proteins in the attribute and the performance series varieties. So it's only those attribute 2 and attribute plus varieties that give you very good earworm control. And then the herbicide tolerant traits can provide some weed control benefits. And then keeping in mind that the performance series does have that cry 3 for rootworm protection. Um, but now we have some questions for you at the end of this presentation. Um, okay, it looks like answers to the poll have stopped coming in. Um, so just going through the responses here, which BT hybrids best control corn earworm? Um, the majority of people chose attribute 2 and attribute plus. So those are the two that have that VIP trait that work very well for the corn earworm. And then what's most important when selecting corn hybrids? The majority of answers say ear size or eating quality, also disease resistance, corn husk and color of husk and kernel, holdability in the field, and insect management traits.
All right, I'm going to get started. So if you are not growing a VIP containing BT hybrid, then you're likely going to need to be spraying silk spray insecticides for controlling corn earworm. And so I am going to be giving this presentation, but this was a collaborative effort across multiple states. So I just want to take a moment to acknowledge all of my co-authors, Jared and Dyer and Dan Gilrein from New York, also Brian Nault and John Mahas from New York, David Owens from the University of Delaware, Brian Currin and Tom Kuhar at Virginia Tech, and Kemper Sutton also at Virginia Tech. So I like to start this with the first question: how long do ears need to be protected? And this is really specifically focusing on corn earworm. And Veronica mentioned corn earworm is probably the most difficult to manage ear pest. But the other thing is that it has become the most common ear pest because it has become resistant to those BT traits, and we're getting less of that area-wide pest management from field corn that we're still seeing for European corn borer. So this is why we're focusing on corn earworm. But typically when we talk about corn earworm, we're talking about protecting the ears from first silks until 5 days until last harvest. Why do we have that answer? I want to dig into that a little bit. So the first thing is that corn earworm moths are very attracted to fresh green silks. And when we look at from some old data, actually from our department in the 30s, as well as some work that was done in Hawaii in the 70s, looking at where corn earworm is laying their eggs on the corn plant, you can see that depending on the study, so this is the older one from Maryland here, versus the one that was in Hawaii, between 30 and 80% of the total eggs that are laid on the plant occur directly on the fresh green silks. Now there are There is egg laying in other locations like the upper leaf surface and the tassel. But typically if you look at the corn earworm life cycle here, we start with a very small caterpillar. So it's a very small caterpillar, and it struggles to get into the ear and cause ear damage unless it's laid near the ear. So this exposed larva is much more vulnerable to natural enemies and insecticides if it's not laid directly in the silks. So after the egg hatches, that caterpillar goes down the silk tube, and from observational studies, they can reach the silks at the tip of the ear in as little as 30 minutes to 2.5 hours after hatching, because they really like the tight bundles of silk. So they usually stop to feed on silk somewhere where the silk is bundled up in a tight bundle. So that may be the very tip of the ear. But typically the early larvae are feeding on the silks before they're feeding on the kernels. So depending on temperature, insects develop at different speeds based on temperature. It takes at least 2 days for an egg to hatch at the fastest that they can hatch. And that's at 90 degrees constant temperature. So typically the days are not going to stay 90 degrees for 24 hours. So it's more likely to be 3 to 4 days that it's going to take them to hatch. And then the caterpillar has to get down to the tip of the ear and grow big enough that it wants to start feeding on kernels. So this is why it probably takes 4 to 5 days before an egg is becoming a caterpillar that's causing damage to the tip of the ear. And so that's where our recommendation is you can stop spraying 5 days before your last harvest. The other aspect of that is, as we mentioned, they really like fresh green silks. They will lay on brown silks, but they typically lay less eggs, and it's less likely that they're going to lay eggs on brown silks. So that's why you can stop. And as soon as you have silks, the corn is going to be the most vulnerable to having corn earworm infestation. So this is how long the ears need to be protected with insecticides. So we recommend that you start your silk spray program for corn earworm when the very first silks appear. We also have some really great thresholds that were based on work from Galen, Dyer, and others in this region. And so this is modified from the Northeast Sweet Corn Production Guide that was published in 1996. And some of the things that I want to highlight here with this threshold is that depending on which trap you are using, the threshold is slightly different. So we have a pretty conservative trap threshold if you're using the Sentry Mesh Pheromone Trap with a Hercon lure of less than 0.2 moths per day is what you need for not spraying, with greater than 13 triggering tighter spray intervals. So that's not that many moths that you have to capture. And that threshold also gets even more conservative as temperatures warm, because as Veronica mentioned, the silk continues to grow. And so you have this unprotected silk coming out, and that will grow faster when it's warmer. And as I mentioned, the caterpillars also grow faster when it's warmer, so they could get down into the ear a little bit faster. So that's where we would have this tighten the intervals when it's warmer. I'd also like to highlight some work out of Virginia Tech. Tom Kuhar and Ryan Currin were looking at using an IPM program where you triggered based on that threshold. And they started their spray program at 10% silks versus doing a frequent spray program where they just sprayed every 2 to 3 days, regardless of what the moth pressure was looking like. And here on the y-axis, we have the percent clean ears. And then we have the untreated control. So you could see they had less than 20% clean ears in the untreated control. With the IPM program, they had to spray 2 to 5 times, but they were getting over 80% clean ears, which was actually maybe even slightly better than the frequent spray where they had to spray 6 to 7 times. But these are not really different. So the IPM program and the frequent spray program were equivalent, and you could save sprays. So it is worth using the threshold, and this was more recent data. So that was using that older threshold still seems to be holding up for Virginia. But what are you going to spray with? So we really wanted to get at this question. It's been tricky because you have to rotate your spray program to make sure that you're managing the residue limits and the max applications per season. And so a lot of times when we're doing these insecticide trials, we like to rotate so that it's more field relevant and more accurate to what growers are doing. But we really then didn't have a good sense of which product is the best. So we took in 2025 in all of these locations with the co-authors that I mentioned, we all sprayed the exact same spray program where we really wanted to compare the different active ingredients that you could be using for controlling corn earworm and see how they stacked out. So bear with me with this table. We sprayed many different insecticides here. What we tried to do is we had ones from that we know people are using, things like lanate here, the group 1 active ingredient. And we also had a couple of different group 3 active ingredients or pyrethroids. So we had both bifenthrin and we had lambda-cyhalothrin. So these are the single AI active ingredients, group 3s. Then we also had Hero, the group 3 that is zeta-cypermethrin plus bifenthrin. So it's 2 pyrethroid active ingredients. And then we were comparing that to just chlorantraniliprole. In this case, it was Vantacor, but it's the same thing as Coragen. We also had Spinetoram or Radiant. And then we had the mixed products that have chlorantraniliprole with different pyrethroid active ingredients, Besiege and Elevest. We also included a product that is not registered in sweet corn, so do not go out and get this. But we thought it could potentially be registered in the future. It's a group 30 planazoline or isocycloceram. And in each of our states, we sprayed this with a backpack sprayer targeting the ear zone based on our moth captures. So we used that more conservative spray threshold of using a sentry trap with a Hercon lure as if it was 80 degrees for all of us. So we were really going pretty conservative with this spray program. And then we also, in Maryland, I also evaluated the growth stages. And so I wanted to let you know, we were aiming for spraying at 10% silk like they did in Virginia. And the way that we evaluated this was if it was pre-tasseling, the tassel was visible in the whorl or above. If it was tasseling, the last branch of the tassel was above the flag leaf. So here you can see the flag leaf is down below. We've got all of the branches coming out in the tassels largely. And if even one strand of silk was visible in that ear zone, this is more than one strand, we considered it to be green silk. And we went through the field and we looked at 10 plants in multiple locations and plots. So here on the y-axis, this is the growth stage, as I just showed you, of the different pre-tasseling is in orange, tasseling is in blue, and green silk is in green, and the number of the 10 plants in each of those locations. And then these are the different plots. So right away you can see there was a lot of variability for me in the silking across my field, where I had some plots that had no green silk at all, whereas I had some plots that were already 50% silking. So on average, across all of my 80 plants that I sampled, I had about 28.8% green silk when I started spraying. So I probably got out there a little bit late. And then just so you can get a sense of what we were capturing in the traps, the y-axis here is the number of corn earworm moths we were capturing per day. We were checking those traps every day and then deciding what our spray interval was going to be. So almost the entire time that I went from silking to harvest maturity, we were almost always in this 2-day interval above 13 moths per trap, except for this one period that gave me a little bit of a break where I had one 3-day interval here. So I ended up spraying this corn 8 times, and I harvested on August 26th and 27th. So we're looking here at the mean percent clean ears, and as I mentioned, I got out a little bit late, so I didn't necessarily get all the way up there above 80% clean ears like we would have liked to see. And as you can see also in my untreated corn, I had 0% clean ears, so I had very heavy pressure the entire time I was doing this trial. The group 1 or lanate is in this gray color. Group 3s are always yellow. Group 28s are purple. So Besiege and Elevest are purple and yellow because they're a mixture of those products. And then we have our group 5 in blue and that unregistered group 30 in pink. And so what you can see for us in Maryland, I got the best control from Elevest and Radiant. And I really effectively got no control from the new product, Warrior and Hero, with the other products falling out in the middle. Now let's compare that to Tom Kuhar's data, where you can see, and for his mean percent clean ears, he got about 40% clean ears, so he had slightly lower pressure. And his best control groups included that pyrethroid that has the two AIs, Hero, as well as having Lanate, Florintronilyl by itself, Vantacor, Besiege, Elevest, and Radiant. So he got slightly different results from me. What is one potential reason for that? So this is an example of a pyrethroid vial bioassay. So we capture live adult moths in our traps, and then we put them in pyrethroid-coated vials. And here you can see they're running around. These are cypermethrin-coated vials, and you can see the moths are still running around. So this is the Abbott's corrected percent mortality. So we could correct it for controlled mortality. You catch a moth in a trap and you throw it in a vial, it doesn't always survive. So we've already corrected for how the controls did on a given night. So in June, we just had enough moths to test cypermethrin, and we only killed about 60% of the moths with cypermethrin in June. That went down to a little over 30% in August. So we did see pyrethroid resistance increasing over the season in Maryland. And we also tend to see, and this is consistent with other sites as well, beta-cyfluthrin and bifenthrin tend to have slightly better performance than cypermethrin and lambda-cyhalothrin or Warrior. But all of these are, again, they're not giving you, in the 2000s, you might have expected this to be up around 80-90% per mortality. So we're definitely seeing some pyrethroid resistance in my area, and it may be that Tom is seeing less of that than we are. So I thought it would be useful to look at across all of the locations. So we had 6 sites where we were doing this trial. And one of those sites had so few corn earworms that we didn't really have any separation in the control, the different insecticides. And one of those sites had such bad corn earworm infestation that we didn't really get separation from those experiments. So the 4 experiments where we could get some separation, how many times were each of these products in the best control group or really falling out like that? So you can see Besiege, Elevest, and Radiant, all 4 of those trials where we were able to get separation, they fell into the best control group. And then there's sort of this next category of insecticides, this next group with Hero, Lanate, and Vantacor, that about half the time they were in the best control group. Warrior was never in the best control group, and neither was that new insecticide. So thinking about the efficacy, our consensus across our project team, they don't like when I twist their arms to make them put this in writing. But we generally consider Besiege and Elevest and Radiant all to provide excellent efficacy against corn earworm, with Coragen and Vantacor, so the chlorantronilyl products by themselves being very good to excellent, Lanate being good to very good, Hero being good, Black Hawk and Entrust. So if you're an organic grower, Entrust is really your most effective product. We rank that as good. And then Intrepid Edge, we do give it a good to very good because the group 5 in there is actually the same product as Radiant, the Spinetoram, so it's a little bit better than the Spinosins that are in Black Hawk and Entrust. We don't think that the methoxyfenazide or the group 18 piece of that is providing much corn earworm control. And then the pyrethroids, the group 3s, the single active ingredient group 3s, are really only fair to good due to that concern with the resistance issues like we were showing with the vial bioassays. So what are some other considerations for making these spray applications? It's really important to get good coverage in the ear zone. So here you can see an aerial application. It's really hard to get a good coverage in the ear zone with an aerial application. And so you may have to adjust your spray intervals and tighten them up if you're using a strategy like that to be spraying your corn that's going to have less residual, less coverage with the pesticide residues. Some other considerations you might also be interested in thinking about are the risks to applicators, pollinators, and natural enemies. So generally when we're thinking about risk, or as toxicologists like to call it, hazard, there's two components to risk, and it's both the toxicity, or how intense the particular product is, as well as the exposure. So a lot of people like to use this sunbathing equivalent, right? So you have these two folks here completely exposed. This one is completely exposed. This person is actually maybe increasing their exposure with a mirror, right? So this is the potential for exposure. How hazardous the sun is remaining the same across the three. And so then you look as time passes, these people put up their sunshade, so actually they're getting less exposure than this person, and this person really got a lot because they were magnifying the effects. So it's both that base toxicity and how much you're exposed. So for the pesticides, when we're thinking about toxicity or hazards to applicators, we're really thinking about one of the easy ways that we put this on there is with the signal word. So the signal words vary for things that are pretty dangerous at pretty low concentrations, so they're pretty potent, so to speak. They're going to be labeled danger, and usually it says danger poison and you have a skull and crossbones. And then that goes down to warning, caution, or caution with an optional signal word as we decrease in toxicity. Now, it doesn't mean that these caution products don't have any risk, but the relative risk compared to a danger poison might be lower. And these signal words are also assigned based on the specific route of exposure that they are going to cause them that are most sensitive. So if it is pretty safe for your eyes and skin, but not very safe for an oral, you're going to still have the not very safe signal word if that oral exposure is of hazard. So looking at our sweet corn insecticides, the group 3s tend to be warning to danger depending on which specific insecticide, and some of these have those cyanide groups that give you the synesthesia or the lip tingling. So these are neurotoxins. Most of these products are neurotoxins, but these are muscular toxins. These are neurotoxins that still interact with human nerves. And of course, lanate also is a neurotoxin that interacts with human nerves. So that's going to be in the group 1 is a danger with a poison skull and crossbones. Compared to some of these other ones like Black Hawk and Trust or Corgin that are caution optional signal words that might be a little bit less risky for humans. So in terms of the toxicity, we have that way to compare these different products, but also you can reduce your exposure by following the label personal protective equipment recommendations. So that's one of the reasons that we have those personal protection equipment label recommendations, and that can reduce your risk of exposure while handling and applying those pesticides. These same principles are going to apply to your natural enemies. So if you think about your bees and your ladybugs, so to speak, or the other natural enemies that might be controlling pests in your field. So looking at the bee toxicity rating, and here I'm using the bee toxicity rating that's produced from a database at the UC in the UC system, the UC ANR. So those group 3s and those group 1s also tend to be broad spectrum, pretty high toxicity to bees. And that also is true for natural enemies for those products. There is some variation, so you can see Intrepid Edge is a medium for bees, but it's pretty toxic for natural enemies from that methoxyphenicide component there. And this natural enemy toxicity, I'm pulling from an application from a beneficials website where a company that sells you beneficials tells you how much to worry about if you're going to pay to release these beneficials. So one of the reasons that we often recommend Coragen or Vantacor, especially during pollen shed, is because it both has low toxicity to bees and it is also less toxic or slightly toxic to natural enemies compared to these other products. And specifically the Coragen or Vantacor, that's a single group 28 active ingredient. As soon as you add that pyrethroid, then it loses that safety for bees and natural enemies. So you can reduce exposure to your bees and natural enemies when you think about when you're spraying, which part of your program, your spray program. So both bees and natural enemies tend to be especially active during pollen shed. We know that this pink spotted lady beetle really likes, it also feeds on pollen and as well as insect pests. So it tends to come into corn when pollen is shedding. And these natural enemies are important in terms of contributing to the suppression of multiple pests in our system. This is a study that we did in the past where we had, these are European corn borer eggs, and you can see this minute pirate bug has come in and fed on some of those eggs. And this is a trichogramma wasp that lays its eggs in corn earworm eggs and also European corn borer eggs. So we do want to consider protecting those natural enemies who can be helping us control pests as well. So in terms of current best practices for applying silk spray insecticides for corn earworm, it's really important, Veronica mentioned this, an ear zone directed application. And anything that you can do to improve the application technology to where you're getting more coverage in the ear zone is going to help during these silk spray applications. And I really recommend sprayers101.com. These are ag engineers out of Canada. They have some really great resources on how to improve your coverage in multiple crops, including sweet and field corn. You're going to want to adjust your silk spray intervals based on moth pressure. And as I mentioned, these days it's largely based on corn earworm pressure, although some of you may be growing corn in places that have western bean cutworm or fall armyworm that you may also want to consider. And both the silks and the corn earworm develop faster in warmer weather. You also want to consider if you had a rain out. If it rained pretty recently after you sprayed, then the residues are going to be washed off and you may need to reapply. You want to rotate modes of action, as I hopefully demonstrated to you in this webinar. Corn earworm is really prone to developing resistance to insecticides, both the BT traits and the pyrethroid insecticides. So you don't want to rely on any one mode of action, and you want to rotate them. This can be particularly tricky in sweet corn because, as we mentioned, we have these products that are pre-mixed. So if you think of something like Besiege, it's a mixture of group 3A and 28. If you rotate to Vanacore, you didn't rotate because you're using group 28 again. Or if you rotate to Hero, you didn't rotate because you are using the group 3s again. So instead, you want a program that's going to look something like you're going from the group 3A and 28 to a group 5 like Radiant, or maybe a group 1A to get that mode of action rotation. So I'd like to acknowledge all of the other collaborators on the team, and of course Galen Dively, who's been a fantastic mentor, and also just sweet corn guru in this area. Members of my lab in the Research and Education Center, farm and staff, grower cooperators who have helped us with this, and the funding sources, which we'll bring back in a minute. So at this time, we have some questions for you, just a couple quick questions about this presentation before we start getting to the Q&A session. Okay, it looks like most of you have answered the poll. So lots of you are paying attention. Yes, Besiege, Elevest, Radiant, Coragen, all pretty good options for managing corn earworm and sweet corn. And it looks like a lot of people are thinking about efficacy against corn earworm when they're selecting their insecticides. Also thinking about reducing risk to bees and natural enemies, product price. So as we move towards the final Q&A session, I did want to take a moment to acknowledge our federal funding. This work has been funded by the Specialty Crops Research Initiative program. The grant started in 2023. And it's coming from the United States Department of Agriculture's Natural Institute of Food and Agriculture. So this federal funding is really important for us in our work, and we're really thankful that we were able to do this project. We wouldn't have been able to without it. And as we move to the Q&A, please start putting your questions and answers into the Q&A chat. We're going to have plenty of time for questions here. But we also have some final wrap-up questions for you while you're thinking of your questions for us. All right, Veronica, you want to field questions first? We got a couple of them on BT things.
Sure. Um, I guess I should read the question. I don't know if everyone could see the question.
Yeah, no,
Um,
go ahead and read the question and then we can start
okay.
the discussion.
So one question that came in says, have you noticed poorer performance from the VIP corn hybrids during extreme high temperatures correlated with high trap counts? We saw this a couple times with the cry proteins before switching to the VIPs. So I have not. All of our trial data that's come in still shows very good control of the VIP of corn earworm with the VIP hybrids. I don't believe this is something that we've seen yet. I don't know. I don't
No,
think Kelly,
I was
you,
gonna say I
yeah.
agree. We've had some pretty high temperatures during some of these during silking and ear production for some of these trials. Especially in Maryland, we plant multiple plantings. So a lot of these have been, and we try to target it for when corn earworm is worse. So we really have very high pressure, and sometimes it's also very hot. And of course, we also have collaborators in the far south, like we talked about in Texas. I don't know if some of and the early warning signs that Texas is seeing has been lab stuff. So far, I would say no, we haven't seen any kind of impact of having those very high temperatures.
Let me see. So the next question related to BT. So what percent of US processing sweet corn is BT? And in Maryland, I don't know. I'm under the impression that not much is BT. I don't know of any that is BT, but I have no idea what percent of processing sweet corn is BT. Um, other than my impression that it's a low percent. Kelly, I don't know if you know anything more
No,
about that.
it's hard to get a clear answer on that. But I'm fairly certain in processing it's very, very low. And I see
Yeah.
Dave also asked for fresh market, um,
Oh,
and Brian has raised his hand. Brian, if you want to unmute yourself and give us an answer, you're welcome to as well.
oh, let's see. I might have to, I don't know if you have the allow. Here we go.
Okay. Can you hear me?
Yeah.
Okay, great. The answer is 0% in the United States. That's
Okay.
an easy one. Yeah, processors won't touch a BT variety because the markets may occur in Europe or in Asia where GMOs are not permitted.
That makes sense.
And then in fresh market, it's a little bit hard to pin down. Um, and we have also asked people if more of them are growing fresh market sweet corn, BT sweet corn now than they were maybe 4 years ago. And we get the sense that maybe a little bit more, there's a little bit more market penetration for BT than there used to be, um, but mostly roadside stand. I'm going to read out one for you, Veronica. Also, are BT varieties available to Maryland to smaller growers like 10 acres? And I think that the question says attribute, but I suspect the attribute 2 and plus are the ones they're interested in.
Um, I am not actually sure what the seed what the size of seed quantities are.
Yeah, I think that there are some that are packaged in quarter units. I don't know if it's smaller than that. Brian, I don't know if you know. Um, I would say like compared to historic, there are more smaller unit options for BT hybrids. You don't have to buy a full unit of seed anymore. But I don't know how small they actually are, and I think it varies also from dealer to dealer. It would be a good one to talk to your seed sales representative about. Okay, we got a thanks. We have an answer in the chat. Look at this. We can outsource this. So home sells 2,500 seed units. I don't know about others. So
2,500 is what I've seen for some of the others, but that's the smallest I've seen. So
okay. So I think that's most of the BT ones. Veronica, you can also get in and type answers. If and people feel free to keep dropping more in our Q&A. So I'm going to go ahead and start with, are controls for corn earworms with insecticides at silking the more effective tactic? Are there other cultural, mechanical, or biological practices that can contribute to management? It's a great question. And this was focused on insecticides today. So having a tighter husk and a longer silk channel helps to some degree. Planting earlier, typically pressure gets worse over the season. That helps to some degree, but neither of those cultural strategies have been effective enough to control the pressure that we have. So really people are largely relying on insecticides. And as I mentioned, those natural enemies are definitely helping, but we have to do these silk sprays so that they are somewhat limited in how much they can help us. And in organic situations where people are trying to release natural enemies or trigger grandma wasps, they're still not getting sufficient control of corn earworm in a no insecticide situation.
can I also add the
Oh, sure.
comment? So just also with the natural enemies, they kind of have the same issue as with the insecticides, where there's not a very long period of time before the caterpillar gets down inside the ear, and at that point, most of the natural enemies can't get to it either. So it's protected from insecticide sprays, but it's also protected from a lot of the natural enemies.
Mm-hmm. So we have a question. Coragen is obviously the best fit for bee safety, but starting with a heavy hitter and using one of your limited 2 to 3 applications when only part of the field has silked, if 10% silk, seems risky. Would you recommend starting with a different chemistry if the field has uneven growth stages, and if so, which one? This is a good question. This is great Q&A. So it is a bit risky. And that is, I think, an ongoing question that as a team that we're starting to grapple with is, when do you start your silk state spray program? And would it be better to wait a little bit later? Especially, if you can get past pollen shed, then you have hopefully less bees active in the field when you're starting that program. From our discussions with growers, a lot of them are starting at tasseling. So I think that having one of those applications when you're in pollen shed, probably for protecting the bees, probably is worth it. But we're also not sure, and that's something Brian is working on, how long that residual control works, especially as the silks are continuing to elongate. Coragen does have that translaminar activity, so maybe you're getting a little bit more out of it then. Um, but I don't think we have the nuanced understanding to say if one of them is particularly better when the field has uneven growth stages than the other. Or even, I have been considering myself whether you should come in early, and if you have uneven growth stages, maybe have a tighter interval before you start that rotation of spreading out the sprays based on what the moth traps are giving you. There has been some historical research looking at even waiting till 50% of this field is silking before you start your program, and whether that works for control. That's not been the direction that we've gone, but that's definitely a question. And if anybody else wants to jump in with their thoughts on that one. While you're thinking about it, we have do any of these chemicals actually kill in the egg stage? I think there's been some historic work that suggests that lannate is ovicidal, or also kills the eggs, but that is actually something I've been trying to persuade my lab. We need to get the permitting to be able to order corn earworm eggs, but we're going to try dipping the eggs in different insecticides to see if any of the rest of them are able to kill eggs. Coragen's mode of action tends to work better as they're growing. and it has to be ingested. So I think you really have to target caterpillars with Coragen, with a chlorantraniliprole. So that's also, someone asked, is there a better time to spray? And I've had people ask me like if spraying at night to kill the moths is better, but you're really not going to get much control in killing the moths. And some of these active ingredients like chlorantraniliprole won't kill moths at all. So you really have to target the larvae that are going to be eating them. Veronica, if you see any great ones in the chat that I'm missing, please let me know. So I have a few here. Does Air Blast Sprayer have the coverage needed? That's one of the reasons I recommend the Sprayers 101 group. And this will be recorded and you can get that QR code, or I can also send around the link. They did a really great job actually of evaluating air blast sprayers and the types of things you have to think about for using an air blast sprayer if that's what you're going to use for trying to control earworm in sweet corn. You can do things to make it better. Having drop nozzle sprayers or going over the top and getting that really good ear zone control would be better. But there are the ways to set the air blast sprayer that will improve your ability to control corn earworm and get good deposition in the ear zone. In terms of what's a good insecticide spray program, group rotations, we don't have a specific program that we're recommending at this time. Part of that is because it really depends on which specific pest complex that you're managing as well. So Veronica brought up stink bugs and sap beetles as being other insects you may be interested in managing, also sometimes aphids. So we need to bring in a pyrethroid, even though it's not so great at managing corn earworm, because it's going to help you clean up stink bugs, or it's going to help you clean up sap beetles. So the specific rotation will depend both on the pest complex, the market, but as much as possible, rotating modes of action is going to help reduce insecticide resistance. Any other questions for the chat? I think I indirectly talked a little bit about, has there been any research done on the time of day to make the insecticide applications? For the labeling for pesticides often encourages you to make your applications in the late evening if you're trying to help protect bees, although I do think recent research has shown that that is not as effective as we hope. But in terms of management of the corn earworm, most of these timings should work, and there hasn't been a specific comparison of spray timing that I know of. I'm dropping that link to the Air Blast article for Sprayers 101 in the chat for everyone. And also as a reminder, this webinar is going to be posted, this recording is going to be posted on cornearwormipm.org. We also post all the other resources for this project at that website. So any updates will be there. And so we recommend you check back with us. Oh, here's another question that I missed here. Does temperature make it less or the same effect when spraying insecticides? There was some research at one point that shows that very high temperatures were a problem for some of the pyrethroid insecticides in terms of efficacy. And I can't remember why that was. But mostly the temperature issue is more about how quickly the silks elongate and how quickly the insects develop. All right, feel free to reach out if you have any questions that we haven't addressed. We appreciate everyone's attendance, and as I mentioned, this will be posted for who you like a refresher in the future. Have a good afternoon.